以给他啊，可以给他。这个可以等下提问的话，就是你可以帮忙讲。
Okay, I think we can start this evening's meetup. Good evening, everyone. Okay, don't feel so tense. So relax. Thank you for coming to this open source meetup. So my name is Darren Chua. I'm one of the organizer. I have my other organizing member here, Jimmy. He will be speaking later. Zach, where are you? Zach is somewhere. Okay, Zach is not around. Zach is our cybersecurity expert. And then Clyde at the back there, who is also doing a stealth startup. So good to see many startups coming up in Singapore. So my real job actually, I'm also working with startups as a tech incubator accelerator. So anyway, I'm glad so many of you are here to learn about open source. I've been doing open source meetup for I think I've done it about 20 over years, almost coming right. We started with Linux meetup. So and every meeting we will always argue which Linux distro is the best. Of course, we had the best. But of course, so I've been doing about 20 over years. I think very happy to see open source actually has progressed a lot, and acceptance and adoption. But actually before my time, there's a person there, Harish. He has actually started this Linux and open source much earlier. He was with Red Hat, and he was also the Linux user group of Singapore. I think that's like 30 years.
34, 35.
34. So that's the guru there. Huh? Okay, I'm also very glad to be working with him together in the Institution of Engineers Singapore. So I guess I don't want to delay further. I want to give you all more time to network and play around with the robot later. So I have the first speaker, Lucas, who's actually originally from Brazil. Yes. So it's came a long way to stay in Singapore. Expert in many things. And he's here to talk about a very interesting subject, not so hardcore AI programming, vibe coding, but building an AI server in your home. Okay, so Lucas.
So today I'm going to talk about a journey that started a couple of years ago, where I managed to get to a working AI server for my own use. In no way I'm saying this is something that is the best way or the only way, but definitely is fun and definitely is more private than the options you have around. So running things in your house, home labbing or having services that you control are always better from a privacy perspective than paying subscriptions and everything else. So unfortunately we have just 15 minutes, so I needed to rush a lot. But if you have any questions or anything, come talk to me in the end. There is way more details that I wish I had time to include, but I don't. So let's go for it. First I'm going to talk about what I mean by a gaming computer. So this journey started by transforming my gaming computer in a gaming server. So a gaming server, I mean, is a computer that is in a separate room in my house, running 24/7, and I can remote access that computer and play games there. And this is an example of something I can do, where I can basically get my phone and connect a controller, and almost from anywhere in Singapore, I can have a reliable enough connection that I can run these games anywhere. Except MRT, because sometimes the signal fails and then you die in whatever game you're playing. But one of the characteristics of the setup of a game server is that the computer is there turned on in my house, wasting energy or wasting the hardware, because if I'm not actually remote accessing it and playing the game, that's wasted. So then come another timeline where I started way earlier, the timeline about home automation. It will make sense why those two timelines cross eventually, but back in the day I started with Gen 1 Alexa and some electronics, and started getting the home automation evolving from my own experience. And for anyone who do home automation, especially by yourself, you eventually get to know Home Assistant. It's a very nice software for home automation, open source, and it can basically integrate probably anything you wanted to integrate. Every brand of devices, every brand of light switches, sensors, things that you want to run in your house can be integrated in a nice dashboard. And one of the things I wanted to do when I set up my Home Assistant is to have a voice control. So as you remember from previous slide, I had the Alexa Gen 1 that allowed me to do voice commands. And I wanted to have this in my Home Assistant. So the way the Home Assistant manages the voice is by having the voice pipeline. So it involves a couple of services. Whisper and Piper mainly are the text-to-speech and speech-to-text. And also involves some large language models to actually process the command that you are asking. So you could run something like, hello computer, in a device like this, that has a microphone and a speaker. And by the way, this device is from the creators of Home Assistant. They recommend if you buy this device, you are supporting the project. It's open source, but you can buy this type of device to help them. And they will process the voice and run the LLM. So when I got to this point of setting up my voice assistant, I needed an LLM. And I had my home, my game server. So those things kind of match. And I started running Olama in my game server to power the voice assistant from my Home Assistant. So this is the setup that I have. My computer is not, for today's standard, nothing magic. I think it's about a 3 years old computer now. And I'm running a really old model. I know for anyone here who is into AI will look to this model like, why you are running this old? It's super old. But I did test newer models, smaller models, bigger models, and nothing really got to the level of reliability to integrate with Home Assistant in the way that I could run in my everyday basis. So then, from the beginning was this model, and this is still this model, and gives me a good reliability for what I need. This model is mostly controlling the house, turn on, turn off lights, everything. So that's why I'm okay with this model so far. But one of the interesting points that I discovered in this journey was when I installed the Home Assistant Android app. So in Android, when you install the Home Assistant app, you can make this app as your main AI assistant for your phone. So the same way as some phones have a Google Assistant or Bixby, in iOS you have a Siri, I can make the Home Assistant my main assistant in the phone. And the difference is that instead of sending this data to Google or to whatever, it's sending to my AI, running in my house. So I can ask whatever I want. I can speak to it and receive a voice response back. Takes a bit longer than the commercial solutions that you can buy from Anthropic, ChatGPT, whatever. But the fact that is running in a controlled environment, that I know what it's doing, how it's doing, my data, access services, MCP services, or whatever I want it to access, gives me a peace of mind that is hard to replace with other applications. Cool. Then in this journey, got to a point where this Home Assistant app running in my phone was not enough. Why? Mostly because of web search. So as you know, in the beginning AI, you mostly we were talking to the model, and we receive answers based on the training data that the AI model has. And that the data could be outdated, could be wrong, or could hallucinate. So once we introduced the concept of web searching for the models, that drastically improved the quality of the answers you get. And I wanted to get that, so I started running OpenWebUI in the same home lab. This was a very good evolution in some ways for the quality of the general purpose AI that I have, but it was also a downgrade from the Home Assistant because via OpenWebUI I couldn't actually control the house automation, or I lost the voice control. So this was an experiment that ran for a while, but I move on from OpenWebUI very quickly because of wasn't a replacement of what I had yet. Then we get into what I use today mostly, Hermes. Anyone who is into AI knows about this. Almost magical how much you can get from a Hermes agent. Even if I'm running Hermes with the GPT OSS 20 billion, the old dummy model, but even with that model, I can get a lot of things done. And Hermes has integration with Home Assistant. So basically I didn't lose almost anything when I switched to Hermes, except that I wanted that the same ability from my phone talking to the model, the same way as I had with the Home Assistant installation app. And that's where I integrated Hermes with a Matrix server. So Matrix is another open source project. The best way I can compare is open source Slack. So you have the concept of chatting, groups, channels, and I included Hermes as one of the chats that one of the people I can talk in my Hermes server is my Hermes agent. And then I can send messages, it will process, return to me. I can do voice commands, it cannot talk to me back. I didn't investigate yet how to do the text to speech back, but I can do speech to text. And it has the native integration with Home Assistant, so I can use this option to control my house, turn on lights, and do whatever I want. On top of that, all general purpose AI capabilities are also there, like asking something to go online, find research, and get the different sources, compile some report, and give me the data. Hermes can do, in my case, it can do via my own my chat message. So another thing I started using my own AI local in my house as well is a project called Paperless NGX. This is an open source project oriented on storing documents. So basically all contracts, bills, employment contract, any document that you have, you can upload there. Has a very good OCR to extract the information and make this data searchable. So I integrated my Paperless NGX with a project called Paperless GPT that gives AI tagging and capabilities to the data that I have. And then basically what I can do is I can go to my Hermes and ask like, hey, does my employer support give me dental coverage? And then my Hermes can go to all the documents uploaded there, my employment contract, find where it is, my coverage, whatever the employer do or don't, go online, matches all the data and tells me, yes, it does, you go to this place, this place, this place. So it's basically I got documents that I would feel uncomfortable uploading to Google, Microsoft, or some big companies because of my employment contract or some very personal data. But I have AI searchability on top, all running in my house. Some of those searches may take a while to come back because of the hardware I'm running, but the fact that it works, in my view, is a big win. And on top of this, how am I actually doing that? I have a bunch of services distributed to make it in a secure way. So my service is accessible online. So how can I make this not being hacked by someone? So I have a bunch of services that with the intention of protecting what I have. Listed here a couple like WireGuard, Proxmox, Traffic, CrowdSec. So each one of them plays a different role in the security posture that I defined in my network. And here's a diagram more or less on how things are working. I'm using two DNS servers, one external, right now Cloudflare, one internal. I'm using a project called Technidium. And in my network, I segregate my services into two types. One public or private. In the very original design, everything was going to be private and I was going to require WireGuard to access everything. But I started having some pushback from other users of my services, and then I split into having public and private. But some low-level services like DNS, Proxmox, or general management, they are always going to be private, and I need to go via WireGuard. And since once I go via WireGuard VPN, then that connection becomes internal network to access those services. Sorry. And on this part about the public versus private segregation, I think the main point of this talk, in my view, is if you plan to do something similar, you will probably want to share this with other people in your household or friends or family or something, so they can also use those services. And I think one of the things I learned a lot from this is that the convenience of some services online from third-party companies is really hard to beat. If you are trying to provide services that you host yourself for your family, the non-technical people tend to not worry so much about, oh, it's private, it's secure, but it's not convenient. And that was the case that I mentioned about the VPN. So I have other people using the services that I host in my house, and the fact that I wanted everything to be via VPN was a very big inconvenience, to the point where they were not using it. But this service is better, it's secure, it's private, why you are not using it? Because it's not convenient. And then I started shaping those services around the convenience first, around having a backup plan first, and then establishing the actual services. There was a time where I sleep with the lights on, because I had a smart light switch that I trusted that smart switch to be always functional. I installed a mirror in front, and then once that stopped working, I didn't have a physical access to the light switch, but I couldn't remotely turn on and turn off that. And I had to sleep with the lights on because there was no way to turn that off. And this is the type of inconvenience that once you try to host services, AI or not, or anything in your house for the people around you, they will love you in the beginning, but as soon as anything stops working, they will be mad at you. So plan properly how you are going to establish those things. That's why in the very first slide, I had a tag here, not production ready, because things will stop working. And for us, it's easy. We can just go there, restart the service, and we accept the fact that things stop working. But the non-technical people around us, they are not like that. So be prepared. Thank you.
Any questions?
Oh yeah, questions?
Take 2 or 3 questions.
Aren't you running Pi-hole in your system?
Okay, that's a good question. I originally started running Pi-hole. Pi-hole, for people that to be familiar, is a DNS server, and the best sales pitch for them is to have ad blocker from a DNS level. And that was one of the things that I stopped doing, because then the people using my network would access some website that stops working because something was wrongly blocked, and then that was actually causing more pain than solving the problem. And then I stopped using that, because then I think it's easier to just install a browser plugin that they could manually deactivate than from a DNS level. Unless I didn't think about having some kind of a smart button automation via Home Assistant to disable that if they need, so there is a panic button they can press to stop the ad blocker. But without something like that, I prefer not to run Pi-hole.
Do you have CGNet or do you have static IP?
Right now I'm using a static IP, but to do the things I'm doing, I think you don't need. I would recommend looking into Cloudflare tunnels if you would like to do something similar without a fixed IP address. Yeah. Cool. One more? Cool. Okay, then. Thank you.
Thank you, Chris. Okay. All right. Next, we have Mr. Ma Chen-Yi. He's the founder of this AI coding startup called Gitmono. So actually, Mr. Ma, I think, flew all the way from China to give this presentation. So so I think he's going to share more on his product, Libra, which is like auditor, right, for the AI coding agents. Okay, so
Take it away.
Thank you. I'm Chen Yima from China, and today I will talk about the version control system for the Asian area. Last week, same thing. Two things happened in one day, and the first is GitHub already crashed down and almost 8 hours. The GitHub service included the auth pre-action is not working. The GitHub side is a community problem, so this has a monthly commit from 1.4 billion up to the 2.9 billion per month. The GitHub service provider feel the agent pressure. It's almost committed from the agent. And the same day, the cursor brought by the SpaceX released a new Git host service is Origin. It's a new host code for the agent. I already tried it. Can sync from the GitHub to the Origin and or Origin to the GitHub, and you can push anywhere. And the display tool side. So it's not that we choose which better or who win. It's actually what's the pressure in the host for the AI agent. The host is more commits from the agent and every day, so the provider feels the pressure from the storage capability or traffic capability. And in the local, it's very different. In one repository, we usually using the different agent at the same time. So we use the work tree in maybe different branches, but make the capabilities difficult to be merged. And also as the agent, when develop something, they maybe try and fail and undo and try again. So it's very different with the host. So the already has some Git tools helping the developer using the agent. The first is Git bundler, and it has virtual branches, the filter. Many agents can working in the same work tree with different virtual branches, and the Git bundler will helping merge together, make a clean commit. Another tools is GG, and from the Google employee, and for now it is already a stable company hosted. Is provided the operation log. Is means the unlimited undo. Agent working in a repository, they can maybe try many ways. Maybe failed, they can undo and undo unlimited undo. So you can get clear the commit log. So the GD and Git bundler is working on the helping the developer working the version control system for the agent. But it's still something is missing. In the version in the Git, we usually host the code and maybe some key commit message. So something is done like when we talk with the agent, we usually promote something, and the agent will be discuss with you, make an intent and make a plan. All the things is disappeared in the version control system. Usually this data is stored in the agent session, but different is if you use the different device or different teams, the session not be shared, so it will be lost will be lost. So what we are working on a new version control system is named Liberal. It's first is Git compatible, and you don't change your workflow. And the second, we define three the AAA and the intent AAA object. Usually the Git is a store 4 objects like the Git upload, commit, and note. We rewrite with the Git internal, so we can add any more and more object like the promote, intent, plan, and evidence, everything. So we can define it as a 3A. So Git is usually manage the code, so Libra also manage the code and the processing data is what we are working. So Git stores the objects, tree, commit diffs, and everything, but it's the final result. The processing data is intent, run decision, as the same the Git objects in our Libra system. So we can link these things, and you can find something. If you use read the code, you can flow the code to get the session. And if you list the session, you will get the result of the code. So when we working, usually we make a bug, we result, and we will be find out what's the result happened. Maybe is the requirement maybe is wrong, or the testing data is wrong. So we find because so we can correct. When we use the agent also can the bug, but we don't have the processing data. The agent maybe make the bug again and again. So this is why we recording this. It's Git compatible, so you can two ways use the Libra init, so you get a Libra repository, or you can convert from a Git repo. So we convert all the Git history to a Libra format, and turn on the capture. You can. For now, we just support the cloud code codecs and open code, and we will be support more like the Pi, Hammers, and others. So you can use the agent like the Euro. You can talk, and the agent will be generate the code. So we catch all the data from the session. Maybe use the hook, maybe use the plugin, and save the one repository. So it's another way. When we using the agent generate the code, so we have the more code and include the processing data. Usually we use a polyrepo. We call the polyrepo means you have the namespace like the GitHub, and in your namespace you have the mutable repository, and every repository maybe application library 1, library 2, library 3. So when agent working, so the agent must find the agent 1, library 1, library 2. Maybe they working with different the repository. So it's very difficult for the agent. But we are working for a monorepo solution. It's inspired by the Google Paper, and it already hosts lots of all the code and the documents in the Google, so you can see everything in one repo, like the code processing data, artifact, training data. We can host unlimited data. We store the data in the use the S3 service. So in one monorepo, you can see the one map by the agent. First is a Git compatible monorepo solution. It's Google has the monorepo is named the Google Paper, but it's used Perforce for the version control system, and Meta used the sampling system. It's also the monorepo, but it used the HG as a Mercurial for the version control system. But we have the solution with Git compatible, so you can clone any folder as a Git repo to the local, and edit something and push it back to the monorepo. So also we working with trunk development. So you just have one branch, is a main branch. So if you have a monorepo, you can't clone in your laptop. Like in our service, we can host 10 terabyte the data. So in your laptop, you can't clone this. So we make a virtual system named the Scorpio FS. Is for now is only run in the Linux. It's like use the Fuse. So the virtual file system mount the monorepo instant. The agent when open a file, the file system is get the data from the monorepo. So in our the virtual system, we just load the folder struct. It's not the data. When agent or someone opens something, get the data from the monorepo instant. So if you're using the Scorpio FS in agent, so the agent will be get everything and the dependencies in one repo. So it's the first we have some task we let the agent do something. You can use the Scorpio FS mount with the monorepo instant. The agent will do something and all the things stored in the libero and pushing the monorepo. The monorepo has all the data, so the agent get everything they can do better. Maybe reduce the agent token cost. So there's this, 3 layers. First is the host in agent area is amount of lot of traffic. So there will be GitHub, Origin, and another thing is Inter. Inter is a new Git host from the 3 months ago. It is developed by the company Inter.io. It has a distribution Git host and sync the GitHub. It looks like the Origin. I think it will be more Git host service in the future, helping the sync the GitHub and let you run it faster. In the local, there's a lot of tools like the GitHub, GitButler, GG, and a lot of others. Today is release a new tools is a DB as from the Z. Z is IDE from the author is the former GitHub employee. So it's a lot of things will be open. So what we do, we write a new version control system like the libero and a mega monorepo host. Monorepo service helping you host everything in your enterprise. We don't run the public service. There's is our laptop, our website and Git repository. So if you're interested, you can try. Thank you.
Anyone has any questions?
It's a naive question. I'm wondering. I like the idea because I ran into the whole GitHub issue last week myself.
Yeah.
What I'm wondering is like I use turbo repo for a monorepo.
Polyrepo or
It's just a monorepo, right? But what I'm wondering is, I was just thinking about this. I know this is a little bit clunky, but what I'm wondering is, what if you put all of the intentions as like general Git protocols? Like, for example, within the message, I can standardize the way that I do all my Git messaging. And then if I want to, I can figure out the intent from the message log itself, right? So what I'm wondering is, the difference between just having a standard about how I do my Git messages, putting intent, actions, etc. within my Git messages. So then I use my traditional Git logs and extract intent and action from that. Does that make sense, by the way?
First is in the different agent system like the Codex or the Cloud Code, they don't split the intent plane or something. They just store everything like a stream, everything in one file, maybe it's a markdown file. So if we want to do this, we must split the data, streaming data into the different object. So if we want to use, we must be extract must be version let the memory using. So in our design, we use the AI let the split the something. Okay, and the second is in the Git in the some object like the entire bit butler, sometimes he use the node. The Git has an object is named node. You know,
Yes.
for now, several some people use the node to store all the session data, but the node not disappeared in the GitHub. The GitHub you can push the node to the GitHub, but in the web you can't see the node. Yeah, but it's a different way. In our way, we rewrite the Git, so we like everything is the object. So we link the object like the DAG, so we can find everything the relation.
Gotcha. Thank you for that.
Yeah.
If I understand correctly, Libra captures agent interactions
Yeah.
and your decision to approve or reject a change.
Yeah.
What if I have a workflow that does not include agents? Will Libra contribute any value?
You mean you not
I
use
don't
the
have
agent?
agents, I just have a manual workflow.
Okay. It's just like the Git. Libra is almost the Git has 190 commands, so we almost
I just use a few, but yes.
yeah we the Git commands is two different. Is the first you use some commands usually is almost 50 commands, and the others is the internal command. So we already implement all the use the command, and it looks like the Git. You just use like a Git and change the name. You don't use the Git, is use the Libra, switch, check out the branch, everything is the same. Thank you.
Thanks.
Thank you, Mr. Mao. Actually, at this point in time, maybe I want to propose like a 5 minutes break. You can get a drink. The restaurant is at the other side. So we will continue with the talk after 5 minutes. We still have a lot of pizza, I think. So if you are most welcome to help us help yourself to pizza. So just 5 minutes, okay? We'll continue. Stretch your legs a bit. Talk to the person next to you.
But a big question, is there a reason?
Sorry.
I would love if you guys could maybe one day, would you do a workshop on how to use this and how you do it in your workflow?
Yeah,
I think that'd be very helpful.
Yeah, maybe someday.
Because I like.
We are still working on it, and maybe has some back. So
Yeah, I think it'd be really cool because I see the point is that if you're having a lot more software development happening with more AI, be able to have like some sort of trace there, it's good. But yeah, it makes sense. What I'm wondering is, yeah, it'd be nice to have a workshop. Maybe I should.
For now, we are working on the memory system. So we just store everything in the Libra system. So if you want to have the value, you must let the agent use the history.
Yeah.
So it looks like a memory system.
Yes.
But it's very different. Usually the memory system is a database.
Yeah.
It's a timeline database or the graph database.
Yeah.
But in our laptop, we can't use the database. We must have a lightly schedule and let the agent use the phone. We are still working on this.
What I find super interesting is that I do a lot of like reverse engineering for educational purposes.
Yeah.
So I like this idea where the Git is all tracked this way.
Yeah.
I wrote a little library like 12 years ago. It's called init, which goes to the first commit of a project, and I always study repositories, right? But what would be interesting is if you had this entire historical part, I'm interested in the intelligence behind it. So for example, like often, like if I look at a mathematical theorem, I always see the output. I never see the process of how the person came up with a formulation. same thing for software. We always get the final result. But so I think what's interesting is that if these agents are all working on a project, and then the trace of how they built it is very educational. That perhaps that's data that you can sell to other people. That's why I find that very interesting. I think right? Because like the process of getting to something valuable, the process is very important, right?
For now, we also want to resolve some problem with we can't reveal the PR by the agent. It's a lot of thousands of lines.
Exactly.
We can't reveal. So
but I think if they synthesize that,
we must see why from the PR from the where what's the promoter, what's the processing is correct.
But what's interesting is like that entire trace, you would compress it and figure out what is the trajectory that gets you back to the outcome, and then you use that for further improvement for your next project, or you could sell that trajectory to somebody else. Because there's an entire process when you develop something. You know, there's a lot of commits that are pointless, and you revert it, right? Or you change the course. I think that's I think it's super valuable. This idea of tracking the tracing history. It makes total sense to me. What I'm just wondering is the competitor to that would be just your typical Git, and then you put all your messaging to be very semantic, you know? And then like, oh, this commit is just like, I committed because this is my intention with some documentation. That's the competitor, which is very clunky, but you know, like people could do that.
For that, some tools like this, say in the origin, they will provide.
I haven't seen that yet. It's interesting.
It's a beta.
For cursor,
the cursor from the cursor is a beta. It must be payment pay user.
Oh, I see.
So
I see.
You can you must in the wait list, and yesterday we talked with my friends. So we discussed. Usually we have an open source project, so we use the heavily, so we must hire someone maintainer. My former company is like the Huawei or the Tencent. We hire some open source project like maintain this. In the future, we don't maintain. We just get the syncing data. Let my agent work.
I like this idea of being able to track every single part towards the development of the project. I think for training and educational purposes, that information is super valuable because we only get a slice of Git history. There's a lot that happens that I think would be super. I mean, for training.
That's
cool.
Some model company like the Moonshot, like the Baidu and Bidance in China, so they are looking for the data like this. All the data is almost is private, so make it more valuable.
And the idea is that if you're building something valuable with an AI system, then the process that gets you to value is very, very important. Right?
So we are working on this. We want to let the developer make an agreement with us. We collect the data, sell to the model factory, and we split the profit with the developers.
Makes perfect sense. I like it.
So when we almost done, we
do a workshop here.
I
think
actually
just to see how the whole process is, because I use Turbo Repo as a mono repo. That's the one I always use from Vercel. So it'd be cool to see. Because before I used Hydra, then I switched over to Turbo Repo for mono repo.
Turbo Repo, I know.
That's the one I always use now. You know?
Usually in China, some developer team has we call the big front team.
Yes.
Means the developer the iOS, Android, Web, and Linux desktop.
Full mono repo.
Yes. We call the front team is so they already use the mono repo.
Yeah, exactly. Thank you for sharing. I look forward to the workshop.
Privacy.
也不是，反正我现在就可以修一个 Slab 嘛，所以也无所谓，什么都可以。没有，我们现在。
Alright. Shall I get everyone back? We can do the networking later. I can't get them back. Okay. Shall we? We'll do the networking later. We have to give the presenters the attention, undivided attention. No. Can we start? Can we start? All right. We'll do the networking. Good. Very good to see networking already starting. Okay, this is what this thing is about. Okay. All right. Okay, we're feeling more refreshed. Okay, our third speaker is actually our very own Jimmy, who has worked very hard to help make tonight possible. So actually, in the past we used to do at least one meetup every 2 months, but I think we've been quite busy. A lot of us are doing startups and all that, so I think it's long overdue. So I apologize for it. So we try to be more regular. Okay, so Jimmy is going to talk about here this product that he has built. It's actually an open source project. So today, all the things, all the presenters, they're all open source project. You can find them on GitHub and try it out. Okay, so I think he's going to share his experience from building MyField.
Thank you. Thank you, Daryl. Thank you, everyone. And so great we have open source meetup again in Singapore. And let's start. And today I will share the lessons about my field. Of course, I will introduce the project, but mostly I like to share the experience and how do I using AI. So a bit is about me. I'm an engineer, and I also love open source a lot. I have 15 years. Mostly I work on operating system, data privacy, embedded, and also cloud native. But mostly around the OS. So I also attended some open source events in the past 3 years to share some talks around the open source, open user community, and also my own project, open source project. So I created my field, and this is I created this year. The original idea is, can everyone own a home in the digital world? So this is quite a hard problem, difficult, especially in this AI era, because the data is quite valuable. But currently the data is owned by platform, and even your account, most of your account, your Gmail, your Drive, your Notion account is owned by the company, also owned by yourself. And even when you buy a domain, the domain is not owned by you. You are assigned by the organization to you. And once you didn't pay for it, the domain is owned by others. So that's why this is the basic infrastructure in the internet. So how we can own home in the digital world? Currently, based on some statistics, the data, half of the time in our one day, the adult will spend half of time, almost 8 hours in digital, in our screen. So digital world also already is half of us. But in the real world, we pursue to own a home, to create our family, to own our house, our unit, right? So in digital world, I think same thing we need to do. But this idea is not from this year. This was rooted in 2013. I already did it on 2013 to 2015. I created the object called IBP Real. It's a personal data management running in Linux desktop operating system, and it is also open source. I pursued the organization to approve me open source this project. So this is the first time I tried to do something around this idea. The second one is 2021. 2 years ago, I created Allspace. It's similar like Lucas' talk around the home server. So it's a personal server to running in your home or in your place you trust. But it's quite different with the last project. It's a decentralized. If you know the DID, at that time, you know the Bitcoin is based on decentralized token. So it's the decentralized account, and end-to-end encryption to create personal data ownership to let you own your account. And it is also with open source. Yeah. So now I introduce this year my field. So currently we talk with agent a lot. So I talk with agent to show what is my field. Because this is my friend's laptop, so I use the privacy model to run the ChatGPT, so it don't have any before context. So it's quite. Yeah, so this is the information, and actually it's quite a new project. It's impressive. ChatGPT already know it, and it's a privacy local first foundation. So the core idea is your data stay yours. So if you are technology, if you are engineer, you may know the local first and the device own the authorization, also encrypted in sync. And for the user to use, currently I publish the 10 field, which is like save web pages in your device. And another one is car field. And let me show something interesting. So this is 10 field, and it's run locally. Actually, you don't need to create any account. Let me show you. Yeah, and I created a bookmarklet, and it's a script. Maybe we use any page to click save. The web page will be corrected as markdown, the content, and is saved in your device. It didn't be published to the server. Totally is locally, and to use any function into it. So this is local first, and it's quite fast and quite secure, safe. So that's why I love local first a lot. And I also, it's just for data and app. This is a web app, right? You know, but it's also included the PWA install, so it's totally run locally, and you no need to create an account first. And so this is the base idea about my field. So you will understand all things is run in your device and no any your data be code to internet. And let's come back. It's just a little bit. Then we can have another question to know more about my field. Not sure whether she can. Oh, it's wrong information. So the AI is not so smart, but if we give it some tips, then you will find my field, and then we ask more about it. Yes, this is right. It's quite an early stage project. So you can feel sometimes AI can provide information for you. It's like a search, it's limited. But some information actually in it is not true. It just shows something. That's quite important. Yeah. So let's come back. Today I'm not here to present what is my field is doing. I'd like to share the experience because this year I used a lot of AI to create my field. During this experience, I think some 3 lessons could be shared here. No matter you are engineer or non-techman. Yeah. So 3 things is first, review early. The second, decisions are pressure, not code generative. The third one is trust. So why this? First one, and the AI is quite brilliant when you start use it, and it generated the code which you just wanted. And but sometimes it will be confidentially wrong. And it's easy to generate not only code, features, docs, UI, test. It's like everything we need for product. But what's the difference? This is 2 weeks ago. I have a talk in Korea, and the open source meet. And the keynote is Greg, the Linux stable maintainer. If you know, Linux is the most important open source project around the world. And he's a key man. And he mentioned the best modes are still wrong 1/4 of the time. And sometimes the bots lie, and the bots like to please you. Like, wow, you feel so good. Yeah, you know that feel when you use AI. I believe everyone experience. It's like you are, wow, you are best. And so the bot is sometimes quite dumb. So what's the problem? When we develop any project or some application, it's not one wrong. We will do a lot of wrong to rotate it, to improve it. So in one turn, you don't have time to have wrong direction. And if you didn't review here, you will go through. And a lot of mistakes you didn't find it in time. And at last, you cannot handle it. The AI also cannot handle it. No one can handle it. So this is the way if you just do writing code. And this, I believe, is the truth. You can use it to do the MVP. It's quite easy. Anything you can want, let it show. But it's wrong for your product. So if you review earlier, you will let it walk into your direction as you want. And you can hold your data you reviewed. So your review earlier is quite important, and review as a root. Review the plan. When you make the plan, when you make the document for the idea, earlier you confirm the information, you will get better information. And the first step is very important. So if you are a developer, I'm a developer, you need to be an architect currently. Not only just focus on code, you need to focus on AI design, focus on storage model, and focus on test cases. Actually, I suggest we review line by line. And in my experience, even when the name, the function name, the AI loves to generate a very long function name and very long notes to explain what it is doing. But it's just didn't have any value into it. Just wasted your token, and sometimes it's wrong. And when you found, this function name is not comfortable for you, it's not the same way as the function others, actually you may find some mistake over there. So currently I enjoy to read the code, especially for product version. So this is the first one. Actually for product, to do design, you review earlier is quite good. The second one is generation. Currently generation is quite cheap, and sometimes we will worry about maybe if we review too much, it will make your project slow. This current AI is like, we need fast again. But actually, every time you make decision, the decision is most valuable, then the generation, then the code generated. Even you drop one. Why? In my field, because my field is doing the decentralized data synchronization across multi-device. So we use decentralized to do the data synchronization. It's quite difficult. It's difficult than the current cloud solution. Current cloud solution, they have a center to decide which one is the truth, the data truth. But in decentralized, it's quite difficult. So this is the hard part for me. And the first time, it's for the update. We need to find the latest data. So we will use snapshot, and also partition to do the things. And also we have the real-time feed. And this is the classical way to do the synchronization. So I use it at first and run it in the past 3 or 4 months. But when it go on, it's quite too many layers and too many requests. You see in this, when one object is updated, the partition will be updated, and also snapshot and also feed. So it's like one updated, we have 4 requests. But actually it's difficult than this one because the snapshot, partition, object, all are objects in decentralized. And we need to decide which one is right, and even more, we need to do CRDT. It's called, we no need to solve the conflict. They just merge it automatically. And it's quite difficult to design this system. So this design, when it go on, is quite difficult to maintain. So, but it's classic solution for the synchronization. So in this month, I try to solve this one. The basic idea is an application snapshot, just the index. So I just remove this one and make this one layer. And what's more is by this idea, we have one object list per bucket. The bucket is like a database. So it's just a list from the bucket. No need to look at object. And although it's incremental, so the conflict is it's conflict free. And also the ID is only, the payload is still cyber text, so the cloud platform cannot see users' data. And after I use this, it's designed to implement the fully recovery for 500 objects. The time consumed from 2 minutes to 10 seconds. It's quite a great one. So, but the partition is quite a key design in the synchronization, especially for a big amount of data. So, but I still decide to drop it, so we drop it. It's like a work in the past 3 months, but it's quite valuable. This value is important for the future. So this is like these things. Maybe it's like we go wrong direction sometimes, because every time we review, we cannot cover everything. But this procedure also is quite important, because only we go through this procedure, we can know which one we really want. And based on this, all the work into it, we will get a bad solution into it. And at this time, we can decide to drop a very big feature left. And then this decision is valuable. And this decision must be made by yourself, cannot be made by AI. Okay, that's very important for this one. Yeah. So actually, the original design is not wrong. Sometimes maybe I also will move back the partition, come back. But currently, I need another one. Another one is quite good. And also do this replacing for early stage project is not quite expensive, but it was worth it. And this value is quite important in AI era. We won't be afraid of making mistake. So this is the third one. This is the second one. So the value is not so much AI generated. The value is you make decision. Okay, so the third one is AI is a tool. This is I learned from my daughter. My daughter is learning in primary school. They also have education about AI. So she told me AI is a tool, and sometimes it will make a mistake. I think, wow, it's quite great. Yeah, quite great. So why you need to trust yourself? First one is, no matter which work you do, you're using AI to do, it's you carry the responsibility. The AI didn't, the tool cannot. So when the business product run, Your name is on it, not AI. Yeah, so you are the one. And the second one is 2014, and hope everyone saw the movie, watched the movie. It's a movie about Alan Turing, and it's called The Imitation Game. Why? Because when Alan Turing is the father of AI, so the test is never about can it think, can AI think? No, it's not. The Alan Turing test is about can it imitate a human well enough that you cannot tell. This is the test. So what's the meaning? It's the meaning that AI is imitate human. It's imitate. It's not, it didn't think. Okay, so this is the second one. And the third one is when we talk with AI, a lot of prompt will first things is tell yes, you are a product manager. You are a senior software engineer from Apple. I think maybe you also use that for month. But I think that we should change it once. It's not what do you think you are wrong, you are a product manager. It's like we should state the problem. We should state the constraints, and state what the code does, what the currently what the project needs. It's not we talk with the people. It's not about the accuracy or the efficiency. It's about the thinking your thinking way. Because when you talk about with the AI like a human talk with human, sometimes it will affect yourself. You may hesitate yourself. Am I wrong? Is the AI right? Because AI is quite powerful and the AI holds all human knowledge, right? So if you, by this way to use the AI, sometimes you will hesitate yourself. But actually, from my experience, you need to trust yourself all the time. You are the best. Because you will do the decision, you will make the judgment. Also, I have some experience about it. First one is translation. And I think a lot of people mention the translation job will be replaced by AI. But from my view, actually it will be improved. Why? Because when you want to use translation service, mostly you want to submit some document to school you are applying. So during this environment, you need a certificate. You need to approve from a company which one is certificate. You know what I mean? If you are not need someone translate you. You need to someone, company or people prove the document to you. Maybe the second one will be better. I talk with the insurance. Think about the AI may affect their industry. But the woman told me, oh, the AI helped them a lot. Why? Because when people talk with AI about the insurance, people will feel, oh, I need insurance more. So they have more business, and they're quite happy with that. You know that? So actually the tool have something, maybe change something, but actually the trust did not. So the society, maybe same as before. Okay, so at last I want to think is about why I taught theory. It's like you are a driver during the AI era. You will use AI to achieve some project. Is you are steering the whole things. So review earlier and decide what to drop, what to continue. And the third one is trust yourself and keep your hands on it. So this is what I want to share in the experience. Hopefully it will be valuable for you. And this is myself. And the QR code also created by my field, which product is called card field. And when you scan, you will get this page. Finally, come out. This is my information. And during this process, my field server didn't get any data. The data is from the link to your browser or to your device. Didn't. So this is the basic idea of my field. Hope you enjoy it. And also, you can create your car and your phone. This is also run locally. And when this is also an open source project, you can find it on GitHub. And also it's local model for AI to recognize the picture. So this is a small project, so you can feel what my field wants to do. Yeah, so this is what I want to talk today. Thank you very much. So is there any question?
Yeah, a question. So if that data, where is it stored? Is it sitting like in IndexedDB?
Oh yeah, IndexedDB in the browser. And it's KV, so it's like object storage. And it will also be encrypted when we do synchronization across different devices. If you pass through the platform, it will be encrypted. Not only the data, and also the object ID together.
And then do you see like you would use some sort of like web LLM or something like that if you want to query information for instance?
Yeah, I tried. Such as this one is older AI technology to recognize the picture. And for 10 field, I try to run locally web LLM to summarize the page. But it's not good. Actually, it's another thing around in my mind. For the cloud AI and for the local AI, they will improve a lot.
Yes.
But maybe in 2 years or 5 years, the cloud AI still will be more powerful than the local AI. So when we want to solve the privacy data, because we need to use cloud AI, so this is quite difficult. This is also I'm trying to solve. Yeah, we can talk about it.
Great.
Thank you.
Okay, thanks.
Okay, thank you very much.
Okay, thank you, Jimmy. Okay. Alright, last presenter for the night. Yeah, make it today. So it's actually we're glad to have Jason from Manual Research Engineer. Just a little bit about Manual Research. The last time actually they did a talk for us. It's the other open source product which is called Gen AI. You guys should try JAN.ai. Actually, it allows you to run local AI LLM in your PC or desktop. But tonight, actually, they'll be sharing with us their humanoid robot, which is also open source, built in Singapore, by Singapore. So we're really proud that they are here tonight to show us. All right, thank you.
Oh, okay. Whose laptop is this? They need to access some media. Oh, okay. Which one is it? It's not video, video. No. Yeah, request.
And if you go to Simlin Square and you see a robot walking around, it's actually them. But I understand they are looking for alternate. They are looking for a new office space. So if you guys know of anything, you can talk to them. They're on the fifth floor, I think. Right? Fifth floor. Sixth floor. But I think I saw the video. It was actually walking in the car park.
Yeah, because level 6 goes space.
Yeah. Okay.
Hey everyone, I'm Jashan. I'm a member of technical staff here at Manual Research. I specifically work on the electrical side of things. So that robot over there is what we built. I work on the computer running on it. So it's this guy over here. So we call it the robot processing unit. And it's able to handle the communication with all the motors synchronously while communicating with like the balancing mechanism and running the ML model on it. So today I just wanted to walk through what we had to go through to get to this point. It's a really, really long journey. So it started about a year ago from now actually. So initially we had a Unitary G1. I mean, we still have it. It's just a box right now in our office. As you can see here, for those of you familiar with the Unitary, this is not how it looks like in general. We had chopped off the red on it, we called it red, put it in a t-shirt, and we had paraded it around. Initially we started as trying to work on the robot brain. So we had a previous product, Gen, helps you run local LLMs. And the idea was to put Gen into this. So we had 2 cameras over here, we were doing some fancy camera stitching and stuff, quad microphone array on top so that you could respond to people in turn. But at a certain point we hit a wall. There was only so much we could do with the Unitree because we didn't own the underlying hardware. And we could keep hacking on top of it, but because it was not an open product to begin with, or it wasn't even exposed or meant to be hacked on, you couldn't really build like a really nice integrated product. So we started building our own. Because we had a Unitree, what we did was that we started abusing it and like walking it up and down, pushing it down and stuff, just to see how the motors perform. So this is what you're seeing over here. I know it looks a bit fancy, maybe you guys haven't seen like a histogram since like secondary school, but it's nothing too much. I mean, we're just trying to see, what are the average values happening, what's the minimum, what's the maximum, super boring stuff. And actually for a lot of robotics, even for something like a humanoid, a lot of the calculations are very simple. A lot of it was just drawing slopes and trying to figure out, okay, if the robot was trying to get up from a place, how much force would need to be applied on the knees? If it's trying to jump, how much force is it going to have? And I mean, a lot of it is just simple F equals MA. And then we started building it. So every single thing on the robot was made by us, except for the actuators. And of course, we didn't make our own computer chip. That's a bit too difficult. So this is some pictures from the initial assembly. This entire presentation will have a mixture of things from my photo reel. So some of the photos might not look very good. So as you can see here, I mean, for those of you familiar with more traditional robotics, usually you have a lot of belts and stuff going across the whole robot. But the new thing a lot of people are doing is that we have this thing called actuators. So it's a combination of a motor, a gearbox, the motor driver, and basically everything you need to actually move a single robot joint. This simplifies the assembly a lot, because all you really need to do is that you put one actuator, you have a coupling, another actuator, a coupling, and another actuator. And you chain that in such a fashion until you build the whole robot. So the exception to this rule were the ankles. Because of the amount of force needed to keep the robot up, we had to do something a bit fancy. Now, I'll talk about it more later, because this led to a lot of problems. Okay, so the first hurdle was getting it to balance. The problem with something that has legs is that if the legs aren't being activated or the joints aren't being activated, it actually can't stand. The motors always need to be powered, and the ML algorithm always needs to be running to keep the thing from collapsing on itself. So first is we had very basic hardware mapping problem, right? So we had the ankle on our robot, so this thing over here, and we had to figure out, okay, how do we take these two positions and map it to the bottom one? The answer is always usually some really basic math. We tried, doing all kinds of fancy things and putting into simulation, calculating the torque output and all that. And it ended up, you just had to sit down for like a few hours and just write it out yourself. So a big problem, and what you usually hear people talking about with robots, right? It's like, oh, the sim to real care. How do you get something that's trained in simulation to work in real life? Usually you hear these values thrown out called KPKE. You can think of it as, in a control system, how much are you pushing and how much are you pulling back? And mapping these two values for each actuator in simulation and in real can be very, very tricky. Part of the problem is that there's a lot of terminology going around. So I know there's a lot of like words over here, right, for those who want to read it, but I think the key thing is just to look at this word armature. So armature in an actuator, and in a real life actuator, it means the portion in the actuator that's spinning, and the forces and the friction and stuff that is linked to it while it's spinning. Now the problem with the guys who make simulation engines, because they never touch the real actuator or a real motor, they use the term armature, but it does not mean the exact same thing, So it's like software guys trying to do hardware, right? And this really annoyed me when I first looked at it, because we were like, okay, no, we gotta go talk to our motor manufacturer, find out what the armature is over there, and plug it into the value in simulation. If you do this, you will not get the correct value, because armature just means a completely different thing in the simulated world. What they were actually trying to say was rotational inertia. So for those of you who have not heard this term since physics class, it's basically when you're rotating, how much force do you have to overcome to actually start moving? So yeah, shout out to Mujoko. Mujoko has had very good documentation of this, better than Isaac Lab actually. And it's one of the reasons why we started using the Mujoko platform. It's fully open source and it's by Google DeepMind. Very good simulation engine. So in somewhere deep, I mean, as you can see, right, it's like Block's omnibus physics in this specific variant, dev guides, all the way down there. There's 2 lines over here. It says that actually the armature value in simulation doesn't matter. So often when you go and look at guides online, they'll tell you like, oh, you have to tune your armature perfectly and all that. But actually, it's just a variable that the simulation engine guys wanted to put in to measure the stability of the physics calculation. It doesn't really have a direct mapping to the real world. So you'll see a lot of people going down this rabbit hole, and I think part of it is that the robotics ecosystem is still very new. So you have a lot of opinionated people writing things, but there's no consensus yet on what exactly should terminology be. So if any of you are planning to start a robotics startup, please, please look at the real world. It's very, very important. So even after mapping the actuators perfectly and all that, right, we still had very, very weird vibration issues. So by vibration, I mean that when the robot starts up, it would just start like spazzing out a bit. Sometimes the spazzing would be small, sometimes spazzing would be large. But this was concerning, right? We're like, hey, we're looking at the system. What could be going wrong? In the end, we realized, oh, actually the problem was that it was not with the real life system. It was that in simulation, the robot had learned to behave like an underdamped control system. So if you look at this graph over here, right, an underdamped control system doesn't have enough pullback force for it to stop oscillating. And the thing about machine learning models is that they're not actually smart, right? You just pump it in with some data and it, through some process, in our case here we're doing reinforcement learning, through some process it figures out how to behave. Because of how we had set up the simulation environment, it had learned that it should behave like an underdamped control system. When you take this and put it in real life, it just mapped the behavior exactly. So I mean, this was on us, there's no one to blame here. Yeah, so this is just, it's just a simple multi-layer perceptron. It's not smart enough to realize that, hey, stability means I shouldn't move. It was just taking what values I was giving it, and because it was so fine-tuned to that simulation world, that's how it ended up behaving. So this was a very important thing, and for every new intern or every new employee that joins the company, it's like a mantra I give to them. It's not about that you have to frame the local motion problem as how do I make the domain of data between sim and real match as closely as possible. At the end of the day, it's all data, right? Whether you're actually collecting data in real life for humans or you have a simulation world, you really have to look at what the distribution of data is before you try and figure out what is actually wrong with the system. There's always 2 parts, right? To every single problem. There's always the system and the signal. The data is the signal part, so you really, really have to scrutinize it. Okay, I'll skip this part because this is just me whining about some documentation. So, I mentioned previously, system and signal, right? A big part of signal that you don't have in simulation is how long it takes to actually send data to the motor and receive information back. We call this actuator delay, and because we own the entire hardware, we're actually able to measure exactly how much actuator delay this is. So we took this pattern of delay and mapped it exactly to simulation, and we immediately saw very good improvement on the robot. This made us realize that actually for a lot of robots out there, what companies are probably doing is that they're building their own actuators and they're building their own low latency communication system on top of it. The lower latency it is and the more synchronous all the actuators are communicating together, the closer it is to the simulated world. Because I mean, in a computer, if I have a GPU, right, I send data, I get it back, I'm basically getting all the data back instantaneously. And the machine learning model learns this. If you don't add this real life delay into your simulation, the robot never learns this. Now, of course, there's always a caveat to everything, right? When you do this, your training speed also decreases drastically because now you're artificially adding a latency to every single training step. But I mean, to us, the reward was worth it. Later on, I'll expand on how we fix this problem on the real robot. So if you look at the left here, right, this is a mesh-based collision box, and on the right side is like a gamified version of collision box. When we first started, we were like, okay, maybe we need to have as accurate of a collision box as possible. We have the mesh, it calculates on every time step. But what ended up happening was that the robot just freaks out because the collision is weird and you don't know how, if eventually I went to go look at the physics engine code to see how it was calculating it, and we realized, okay, for our specific use case, a mesh-based collision doesn't make sense. So we just simplified everything, went back to just cylinders, and we realized why they've been doing that in games for like 30 years. So this is a bug we had. We termed it the 4D bug. Eventually, we found out the root cause was that our actuator was sending us back garbage data. So till today, 1 year later, I don't know why it does this. It occasionally just chooses to send us a random data packet that has nothing to do with the rest of our communication. Now, this is probably because our supplier doesn't use a standard actuator communication protocol. So they use this thing called CAN, the Control Area Network, invented by Bosch 30 years ago. It's a very good protocol. There's also another protocol on top of it where you're supposed to use when you're using this electrical protocol. Our actuator supplier does not do that. So it leads to some weird behavior. Initially, we were blaming this, we're calling them, telling them, like, hey, why is your actuator broken? So yes, the actuator is not giving us the right data back, but that wasn't actually affecting our performance. What this did lead to, though, was that due to us scrutinizing every single part of our system, we realized that our data from the motors was not coming back evenly. Now, so what do I mean by this? So I have, let's say for the bottom of the robot, right, I have 12 actuators, starting from the hip all the way going down to the ankles 6, and other side another 6. Let's say I send to the first motor, and the second motor, and to the sixth motor at the same time. When I receive the data back, I might not get it back in the same order I sent it if I did not wait on each set. So initially how we were doing it, we'll send 12 sets of data and we expect 12 sets of data back. This was causing weird issues in that when the data came back, it wasn't coming back in order. This out of order behavior, from the perspective of the model, looked like invalid data. So because of how small the NLP was, it was only a 3-layer NLP. It could only see the current time step and one time step into the past. This meant that actually, let's say you missed a time step, or let's say your sampling was slightly different from the previous one, it will look as if it skipped in time. So now imagine you have a graph, right? You know, a smooth graph going across your XY plane. If you were to change the sampling rate, you'll get a completely different graph. And that's kind of what the model was seeing, right? You're basically panicking. Oh, yeah, this is what I just explained. So the reason why the impulses were a really big problem and why it was triggering the issues with the whole system was that when you have a big jump like this, right, it looks like an impulse. And if you've gone through a signals and systems class before, usually impulse is one of the first things you learn. You put an impulse into a stable system, nothing happens. You put an impulse into a system that behaves like an under-damped system, it starts vibrating like crazy. So this took us about 200 locomotion policies to figure out. 200 is a lot. It was a lot of 9 to 9 days, or about I think a month, but we finally got it. So another big thing was how does the robot feel the ground? So a weird thing about locomotion policies today, and it's a limitation of the hardware as well, which hopefully changes with time, is that it doesn't actually take force feedback back into the policy. It only takes position data and velocity data. This means that it has to infer how much force it's feeling on each of the joints. The problem is that on current hardware, it's very difficult to get accurate force sensing without a specialized sensor. And you just don't have space in most actuators today to fit that sensor into it. This will probably change in a few years as the cost goes down on more modern sensing. But till that happens, you need some way of the policy to feel the ground without it doing it. And this is where machine learning is really nice, right? So we had an active critic-based system where there was some privileged part during model training that had access to all data. Then the model would learn the mapping between the privileged data and the non-privileged data. So taking position and velocity information, it could infer how much force it was feeling on the ground. So this isn't perfect, obviously, but it was good enough that the robot started pushing against the ground. So if you lift up the robot today, it would actually try to feel the ground and shake its legs a bit. It's quite funny, but my personal theory is that I think the Unitree, which probably has the best locomotion currently in the industry, uses a mix of traditional controls and also machine learning. Because with traditional controls, I can take the current data and I can hand tune it till if the current is this amount of value and this is how much force is being applied by the actuators. We have not tried this yet because it's really difficult to do, but we hope to get there one day. Okay, so this was quite a dumb thing. This is why you should not use AI code for everything. At one point, we had used Claude to edit our XML, like the version of our robot in simulation. And this had resulted with the toe being slightly more into the ground than normal, which was causing the robot to always think that it was falling down at the beginning. So every time you start up the robot, you'll try and do a jump or whatever it is, or you put too much force on the ground. So one day at like midnight, I was like, okay, something has to be wrong with the simulation model. So I went to look at it, and eventually I took this photo over here from the side. I'm like, okay, you guys, no more Claude on important things, only human eyes. So with each robot joint, you actually have to set the 0 point as well. This is usually overlooked a lot because sometimes your actuators come pre-programmed or your 0 point is not very sensitive. But on a robot with 12 joints, it's very, very important. If each joint is off by about 5 degrees or maybe even 1 degree, the error compounds and you can see very weird behavior. So to get the robot to be really, really straight, and this was when we were not very sophisticated yet with our software, we had 3 guys hold the robot down and lock every single joint. And while one guy whose only job there was to click the 0 button and then everything would be set perfectly straight. Yeah. This also improved performance. So finally, anything which really allowed us to cross the barrier from like, okay, this is not bad, to this is like super, super smooth, was adding a low-pass filter after the ML model. Low-pass filter, I really like them, so I'm an electrical engineer. I like traditional signals and systems. None of this ML fancy stuff. We could not get the same level of smoothness trying to bake it into the model itself. This could be a skill issue on our part, but all I'm saying that low-pass filter is like one line of code, and this was the single greatest improvement in the robot stability. Yeah, so I've talked a lot about like the actual hardware itself, sim-to-real gap and all that, and actually there's not much RL here, and that's because we actually didn't have to change much. Once we solved this problem, the policy just worked. There's another company out there, open source rewards. We looked at Boosters One, we looked at some of the stuff Unitree did. When we use that stuff, yeah, it kind of just works. And a bunch of the things that you need to do was actually making sure you had a very stable hardware platform and you mapped that hardware to simulation. There wasn't really much on the RL engineering side. Now, this will probably change as you try to do more complex things like doing a backflip or crawling on the floor. Maybe you're trying to take vision into it. But it's nice to know that at a baseline, the skill ceiling that you have, or the skill floor that you have is not that high. It's still surmountable. So these are some videos from right after we got it working. So this is me, Falcon kicking it from the back. And this is our team lead Celine. He's really knocking it over, right? But it's quite stable. So, okay, now that we've done half the body, right? Now it's like time to build the full body. We thought this would be like, we were joking, it's going to be 0 shots, super easy, we already done it in the legs. This was terrible. So going from 12 motors to 25 motors, I mean, now that I'm looking at it now, it's doubling of it, right? We probably should have known that it's going to be very, very tough. And part of the problem was that, hey, on 12 motors, your latency requirement is not that bad. You have a lot of time, 200 Hertz, so what, 5 milliseconds to communicate with 12 motors, that's okay. Now I have the same 5 milliseconds to communicate with 25 motors. And to make sure that everything else that I mentioned previously all comes back in sync, that was a real challenge. So eventually what we ended up with was this architecture over here. So we used this board called the Rexa CM5. It has a CPU called the RK358. It's got 8 cores, 4 A55 cores, 4 A76 cores. So in more layman terms, it's got 4 efficiency cores and 4 really powerful cores. What we did was that we had a single Linux system running preempt RT. So it was a real-time Linux system. We tuned each of the threads that communicates with each of the motor CAN buses over here. So each of this represents one limb. So it's left leg, left arm, right arm, torso, and then finally the BMS, which is the battery. Because the CAN communication protocol, it was designed for cars, your consumer chips don't really support it directly. The RK358 does, but it's bugged. It's a hardware bug, it doesn't work properly. You get weird behavior when we use it. So we had to find a way around that. What we did was that we found this chip that allowed us to transform SPI, which is a common CPU peripheral interface. I mean, that's what it stands for, serial peripheral interface. and converts it into CAN. Very nice chip, the MCP2518FD, I think. I can talk about it more later. I love the chip, it's great. Oh yeah, so this is just an example graph of what I mentioned previously, so these are discrete samples over time, right? And if you were to plot the graph, it goes like this. If let's say you were to miss this sample here, miss this sample over here, instead of seeing a downwards spike, you would see an upward spike. And this means that your policy behaves completely differently. It's fine if all your voters behave this way, but let's say if on one CAN bus, if one CAN bus has the spike and the other one doesn't have the spike, you get super weird behavior. This is how you get your robot doing somersaults or one leg spinning backwards or whatever else. So on the final robot, we actually have a two-tier architecture. One is just handles the media and the Wi-Fi, and another one is actually for motor control. This gives us a lot of flexibility and also a guarantee that if anything happens on the top robot, let's say a user uploads code to this, or someone vibe codes something that eats up all the CPU resources, the robot can still keep balancing. This is from past experience with wireless networking and all that. We realized it actually eats up a lot of clock cycles. If you open up a VS Code instance on this guy, not VS Code instance, but if you know VS Code has the remote server feature, if you remote server into this thing, it actually affects the walking of the robot because it takes up CPU cycles from everything else. I mean, you can do isolation and all this other stuff, right? But at a fundamental level, it's very hard to isolate different processors on the same CPU or on the same set of CPUs without having some kind of virtual machine. But a virtual machine also adds even more delay. So the conclusion was separate it and make sure you gatekeep as much as possible on the fundamental motion control while leaving you freedom to interface with humans in the outside world. So this is just a picture of the motion control board, which is the bottom board over here. We call the entire stack up the RPU. It's made of this board over here and this guy on top of it. This guy isn't very interesting. Just you plug in each of your left leg, right leg, all the stuff, so make wiring super easy. But this guy is the one which actually has the conversion chips. So these are the ones I was talking about over here. It's a simple board, but actually there's quite a lot going on it, just to make sure that all the communication is as consistent as possible, and every single thing was impedance matched and keeping the traces as even, so electricity flows really, really well. And this is the Ethernet board. So this board over here actually sits in the belly of the robot, right at the bottom. And the Ethernet cable flows all the way from that to the side of the torso. It comes up from the neck. Later on, I can show it to you guys. It's a blue cable that goes straight into the RPA on top. So this board over here, I just want to shout it out because it's designed by an intern who worked with us for a bit. So he's still a high schooler, so that's very impressive. Yeah. So this works as our media board. So this is what actually has the two stereo microphones. There's one microphone over here and one over here. And it has a speaker board. We can support two speakers, but currently we only have one on the robot because we couldn't find space to fit another one. And then finally, this is the most boring one. It has a button, it sits on top of the thing, it's meant just for user debugging, and a buzzer for low battery, which is surprisingly important. Okay, so that's everything for today. If you guys have any questions, I'll be happy to answer them.
Do you have use cases in mind for the robot, and do you have pilots upcoming?
So, for this guy over here, it was built mainly for local manipulation research as well as local manipulation deployments. The goal wasn't for it to do like poor manipulation tasks. So actually the robot only has 5 degrees of freedom, which is not great, right, for reaching stuff on the table or rotating its wrist and all that. But it's mainly a development platform, and we're actually currently selling it. So initially we had pre-orders. Now we're shipping our first batch probably in the next 2 weeks to people who are starting their own robotics companies or university labs doing locomotion research.
Like an educational product?
Yeah, it's a mixture of educational product as well as people who want to get like a step into the whole humanoids ecosystem. So the interesting thing about this, our go-to-market strategy was to sell it as a DIY kit. So you don't actually get a full assembled robot, you get a box of parts that you have to assemble yourself. And we have a whole manual online, and nearly everything I showed you over here, there's a more detailed version on docs.manual.ai under Asimov 1, where we walk through exactly what each part of the robot is. I mean, we built this robot to solve our initial problem, right? Was that when we bought a Unitree, we couldn't do anything with it. And we want to make sure that anyone who buys an Asimov is able to do whatever they want with it. And maybe they have to do extra work, reprogram firmware or whatever it is, but it's definitely possible. And we don't want to gatekeep the experience.
For your robot processing unit, I understand you use a CM5, a Ratsa CM5, docking over SPI to your converter chips to CAN. Have you considered using multiple microcontrollers instead of CM5 docking directly to converter chips?
Yeah, so I'll go back to the picture of my team lead kicking the robot. It's a bit relevant.
Okay.
So our team lead, you can't see his full face over here, but our team lead over here, he was very against microcontrollers, and I was wanted to use microcontrollers, right? You have multiple super deterministic, you have them communicating with each bus, and then you have maybe a USB interface or something.
Or SPI actually.
Yeah, exactly, or SPI or something to do with, right? And then he told me one thing, is that if you can get it to work with the specialized IC, it's as if you have code baked into hardware for you. And that's 4 lesser chips that you have to maintain, 1 less code base you have to maintain. I mean, in hindsight, he was right. He's not here today, so I can say it.
So more parts to break, that's all.
Yeah, it's more parts to break, and it's not something for you to own, right? And the chip we're using is actually supported by Linux kernel already. It's amazing Linux kernel.
Offload a lot of processing to the microcontroller.
Yeah, you could, but at the end of the day, you have to solve a lot of fundamental problems as well, like passing the packets and all. We probably could get more control. Maybe we could drop the latency even more, but we don't think the trade-off is worth it at this stage. Yeah, we might consider it if, let's say we had a microcontroller that could do like 8 CAN buses at the same time. So then you have a single base. I don't have to worry about concurrency between multiple microcontrollers. I only need a single one.
Yeah.
I can offload more of my firmware processing directly to the microcontroller itself.
I can think of chips with 2 CAN buses, but not 8.
There's some coming out now. I think NXP has like the SK32 or something like that. Yeah, but it's currently paywalled, so I'm still trying to get my hands on it.
How much are you selling?
So the robot's a bit expensive. We're currently selling it as a DIY kit for 20k USD.
Wow.
Yeah.
Enrichment store.
Yeah. So that's why I mentioned that a lot of it's like usually bigger labs or either people who have been founders before and they're looking to start a robotics company. So they really just want a robot to tinker with and really understand what's happening and possibly build off in the future.
What do you see as a business model?
So currently the business model is sell robots. So we take a margin on selling the robots and plan to sell more. We'll probably offer an assembled version of Asimov 1 soon for a higher price. We're working on extending the hands so that it can be used for manipulation tasks. We're making a pair of grippers. I actually brought the grippers with me here today. So this guy over here on this thing. And I mean, the robot is extensible, right? So probably for the next 6 months to a year, that's going to be our goal. Just keep selling more robots and try and make it as useful as possible for people.
As a follow-up, do you see that perhaps the infrastructure and the simulation and training would be like, you would get to a point where you give the robot away for free, and the simulation, the infrastructure, all of that would be super hard for anybody to take that on, right? Is that something that you have in your future?
So that is possible. We do have, I mean, our company isn't just a hardware company, we do have our own AI arm, but that's where we started.
Yeah.
And we also do, as you mentioned, simulation environments and all this stuff. I think the current challenge is that no clear winner has emerged yet for simulation engines. There will probably come a day where that'll be true, where the hardware becomes so commoditized and so cheap. And that's the promise of humanoid robots, right? If everyone's building the same ecosystem, the actuators become like a spare tire. You can go to any shop, I can replace it.
Yeah.
CNC parts and stuff, the price will just keep dropping.
Exactly.
So yeah, I think there'll probably be a more in simulation, but I think my bet will more be on the model side, where I think generalized physical AI models will take a while, and what you might see in the near future, similar to in computer vision, we have specialized models which just do really set things, and people who sell these things are probably going to make a lot of money. It's similar to like the craze with like the Android App Store or the Apple App Store.
Very cool. Because one question, you said you guys are not using much reinforcement learning right now, right? It's more deterministic, like functions, basically?
Oh, no, we use a lot. The whole thing is reinforcement learning. Yeah,
okay.
the whole thing is reinforcement learning. What we do want to move into, maybe some parts of the robot control to be more deterministic, but we're still exploring a mix of, where do you use your traditional controls and where do you use RL? mixing those together can sometimes have undesirable effects. So we're still testing.
In your just out of curiosity, in that RL training, do you have, it's not as sparse feedback, because you have quite a bit of noise, like a lot of data, right? Is all that data useful, or do you like sample out like information that's not needed?
So not all the data is useful, but currently there's not enough data for us to throw it away. So we don't take in false data because, okay, so the rule of thumb we have is that if we can't get an accurate sensing of the data, or if we can't sample data accurately in the real world, we don't use it in simulation. Because the moment you have to deploy a model, you have no way of actually passing the data in. It doesn't matter how well it performs in simulation, because it'll just never perform in real life. It's a bit weird compared to other fields of machine learning, right, where you have test data and you have training data. In this case here, there is no test environment either in the real world. You're basically overfitting into simulation and you're deploying into real life. So that paradigm shift is quite important.
Great.
Yep. Thanks everyone for listening to my talk.
Thank you, and a big thank you to all the presenters today. I really wanted to give you all maximum exposure and time to interact and ask questions. I think Melo will still be here for a while. I don't know when we need to leave this place, but before we end, last call, we are still looking for more speakers and more volunteers who's willing to join our team. I've been doing this for 10 over years. I think I want to take a break and hand it over to the younger generation. So once again, thank you all for coming tonight. All right, please network and finish up all the drinks and pizza. We'll try to share the slides. Maybe I don't know if Loma we can post something, or we'll email to you the decks as well.
Thank you.
Okay.
Okay. Oh yeah. One more plan. Yes.
Oh yes. Maybe we'll leave like by, I don't know, 15 or so. If you would like to join us, I think we would probably adjourn to just opposite next door for some drinks and casual get together. So feel free, you're most welcome to join us.
Thank you very much for organizing. It was great.
Hope you can join us next time. But and if you have something to share,
Yeah, at the moment I don't have much to show,
but it doesn't have to be your company. Like just I want Lucas to show his own project or something that he is using open source to you can also share. So it's not like you have to be a company or
This is a really old robot. So maybe see you
all the
soon.
best. Yeah. See you next. Or you can join us later. I thought this is a good excuse because I'm going to the open source meetup. Very safe. You won't be any girls.
研究会找这样子的情况，因为我不是很了解这个，但是我想说，感觉像是这个版本这一块，是你的这个在讲的，然后我发现这段时间我在新加坡，跟我们讲述蛋糕，就是蛋糕的挑战，还有什么东西这种东西，所有的产品都很不是，因为很多时候是现在的国际的法规还没有出来，标准很多，但是如果有一些把这个当成
它有它的消费者是你如果你消费者cloud的话，你和这个数据相比，就是他自己对待自己的数据，但是你只在自己的数据上做，你不会它是有它的，然后大家都是，但是如果我在这个层面上，那我就应该搞多少？我这个是所以说应该我们应该要做一个这样的因为每一个人他们是买的，因为他们把这些东西拿出来让我
我就想说，GitHub那比如说然后就可以做成
因为他们其实他们是他没有这个，我就是软件，还是他们。
但是我去 GitHub 我去下载一个，如果我也我也想这样子，那我就
你是说的他是但是说那个聊天的时候，感觉你这个，比如你跟 ChatGPT 聊天，你就感觉是他可能就会开始，因为我知道他或者是你三一般人，对吧？所以我们想把这些数据都收集起来，那我认为可能就把这儿的消费者方式，像这个是这样的，就是如果用户要跟我的用户觉得说，我愿意把自己买，你用给我，比如我先从他这里买，如果不愿意，那跟我签合同，然后打包，有的人还是买，所以他这个车他是很难的，因为现在的问题就是对于用户来讲，车下，然后。他的也不是像我们开的 VC 会把数据做成 那我如果能够做到包括所有的人在用 AI 的同时，你还能做。对，我们希望可以。其实因为现在大家知道的这跟中游，中游是我这个模型，然后呢，我的训练数据不够，就是不是他问我就去问他人，对，他回来告诉我，然后我再告诉他，然后这样我就拿好多数据，我也知道他们怎么答，然后把这个怎么一下。
你的这个书写动作，他们会懂。
所以他们那个，其实老外也是拿中国一样的，他们其实在问什么？他问其实腾讯和阿里有什么大的区别？我已经
对呀，无敌了，真的是。
腾讯他挺有名的，
就是啊。
我以前我曾经去旅港，我当时19然后他们说为什么腾讯的那个图像识别做的最好？
做不了的。
对，但是后面会烧柴了，然后上个月刚回来，然后在这边第一个，因为我先是一个要求的。之前我们还要不要回上海？
那你对这个有兴趣？
哦，非常有兴趣。为什么？因为我当时做有的时候我做那个叫第四方面 first development， 它其实也是一个科技的这个简单的一个其实就是科技的小的。所以呢，我当时也是看去给客户去搜索，然后我又是 product manager， 我要跟 engineer 说，我要跟operation 说，跟哪个说，所以我就觉得我当时的重点是。做口语，好多东西没有办法实施，然后因为上来再解决了，对，所以我就开始做这个有一些慢的。
这个人形。
对，我刚刚说为什么一定要人形呢？我自己家的小飞机是我可开心了，一个 delivery 的这个。
他觉得人形是一个最终极，如果是实用型，真的会不实用。工业的它其实不用，它是有人或者是用这一个任何动物。然后5月份的时候，曾经去了那个北汽的看着后面，所有的这个汽车8月份车日它的80%全部都是机械，它是一个终极，大家这个最终的一个挑战，要把它造出来。人形机械这个价值是还要陪伴它搞得人。我也去看国际大厂，它没有感应，它也有感应的，它是感应的，没有办法的柔性皮，那个不是，但你需要这个东西，因为你要做的那个没有是很你要，比如说要去做，对，或者他们的什么康复啊、医疗啊，老人或者你要把它给捏碎，所以这个东西要做很精巧、很敏感的东西，那个是需要他们现在没有这个，他们开始20档次的，他的那个不上嘴，中国科学院就是中科院，中国中科院的人才大多还有。其实会现在很多都在这个一个主要做的还是假的，最重要还是档次。他那个他在脸上是有他在脸上只要25个点，然后再加上你那个是对，那个是如果要抓都是抓鸡蛋啊。对啊，那有人抓豆腐，有人抓豆腐，我就说你是个，因为我是能做饭，能抓白粉都没抓起来，那个就是真的 也是在新加坡很有名的，他也是老大了。我跟他讲他的产品，因为他现在他真的大，全都在用 AI， 用 AI 来管理一下。在重人生的活，他在要。然后他越拿越有，他要管理，大家都用 AI 很乱的，It's called Meetup. In reality, 他们是上次没有他们做照的，还有制造厂类似做管理代码管理，另外两个
Thank you.